Okay, so let's talk about VPCs, virtual private clouds, as we know them. And this is your private network within AWS. So when you first start working with AWS and you maybe launch an EC2 instance, and we're going to get into EC2 instances and how all that works in a short while, but once you launch an EC2 instance, which is just a machine in the cloud, you need to position it within a network so that you can control who has access to it, which entities have access to it. And in order to do this, we need to have a set of rules that surround those EC2 instances. And as such, you can see on this diagram that we have EC2 instances signified by these orange blocks. And each of them have what we call a private IP address associated to them. And on this interface, we can apply security rules to determine which set of machines can or cannot access said resource. You may say, okay, well, this machine over here can be accessed exclusively by this machine, but say not this machine. That kind of thing. Okay, and that's what we're going to mean when we talk about something called security groups. I'm going to get into security groups in a second. But as you see, these EC2 instances are associated with a private IP. What you're looking at here are public IP addresses. These mean that when you have someone from the outside world trying to reach your network, providing you allow them access, of course, because you have that granular control, they are going to be able to access these resources because they have publicly routable IP addresses. Okay, so let's see how these IP addresses break down. Let me cover this slide first and then I'll explain how the IP addresses work. So when you create an internet connected VPC, there's a few things you're going to do. You're going to have a public IP address for the machine, otherwise you're not going to be able to route to it. You're also going to need to choose a range of IP addresses to define your entire network. Once you have that range of IP addresses defining your network, you'll carve that up into what we call subnets, or smaller ranges of IP addresses. And what people tend to do is separate subnets generally by internet access. So you'll have one subnet or range of IP addresses that can access the internet, and you'll have another range of IP addresses which has machines in that don't access the internet. So you tend to separate subnets like that. You'll of course need a way for your machines to be reached by the outside world, and you'll do that by creating a route to the internet. Obviously you're going to need to authorize traffic to and from your VPC. That is done with those security groups I talked about. So let's just jump over to choosing an IP address range. So those numbers that you saw on the previous slide, what do they mean? Well, an IP address is 4 numbers separated by the period symbol, which you're looking at here. It's a typical IP address. Okay. How do you choose the IP address range for your VPC? Well, it really depends on what you're trying to achieve. If you already have an on-premises system that has its own range of IP addresses, because you already have existing machines, you really want to make sure that that range of IP addresses don't overlap the range of IP addresses you create in the cloud as well. Okay, otherwise you're going to have routing problems. What you're looking at here is an IP address, but you'll notice it has /16. This is literally a shorthand way of writing a range of IP addresses. Now, in previous courses, perhaps in advanced architecture, we would go into a little more detail about how these IP address range syntax are created and what these /16 means. At this stage, I think for a very high level perspective, for those who aren't that familiar with VPCs, I wouldn't worry about it so much. It's just focus on it being shorthand notation to describe a range of IP addresses. If you're already in the networking world, you already know what this stuff is anyway. So let's talk about the subnets. We have one big range of IP addresses here, /16. This is a big range of IP addresses for the VPC. And then we have smaller subnets on smaller, even though the number's higher, smaller ranges of IP addresses for each of these availability zones. As you can see, these are availability zones. We talked about that earlier on. So we have 3 AZs, we have 3 individual subnets, and by default they're all going to be private. Why are they private? Because you haven't created a route to the internet. And because they are not creating a route to the internet, they're defined as private. If you want it to be public, guess what you do? You add a route to the internet. Okay? So, route tables define where your traffic is moving. So your VPC is going to have a default route table when you create it. But obviously, because we like to give you the power to do this, you can go in there and control different route tables for different subnets to control how your traffic moves in and out of your VPC. So this is what it would actually look like if you were to go into the console and see your VPC route table. This is a range of IP addresses here, cider block, and this is saying any traffic that's destined for any interface or machine or IP address in that range will be routed locally, which is what you want. As you can see here, this is an internet gateway inside your VPC, and if you want to have traffic reach the outside world, you're going to need to have this internet gateway, otherwise it's going to be a private subnet, isn't it? And you're not going to be able to route to the outside world. So how do you package that into your route table? You're going to do it like this. Here's the original rule you had, saying all traffic destined for the local VPC is going to be routed locally, as you'd expect. But anything outside of that range of IP addresses, signified by this 0000, will be sent to the internet gateway. Therefore, when traffic goes outside of this range, guess what it does? It goes to the outside world. Okay? So let's talk a little more about how you secure that and lock that down a little more with network ACLs and security groups. With network ACLs, what you're essentially doing is going one step further than the traditional security group. Remember I mentioned security groups before, that they rely on the interface, they work on the interface level, deciding which traffic or which entities can communicate with each entity. Well, the network ACL is a little higher level than that. What it does, it controls traffic in and out of the subnet layer. Now, in many cases, we find having control over the network ACL is probably a little bit overkill. I mean, if you're locking everything down at the security group interface level, that's probably good enough. But in some cases, especially for things like compliance in certain organizations, you might need to have an additional set of rules determining how your traffic is coming in and out of your defined subnets. And that's what a network ACL allows you to do. So the English translation to all of this is allowing traffic in to your subnet, which is probably what you want, right? There we go. That's what it looks like. If you were to go to the network ACL section, you would see allow and deny rules. Okay, the higher number rule is going to win. That's the way that works. But really, I think the most important part of locking your network down, and the thing that I really want you focusing on, is not necessarily the network ACLs. Be aware that they're there, but focus on the security groups. Because what this is going to do is determine which entities can communicate with your other entities, such as whether these web servers can communicate with the backend servers, whether you might have internet access from here, allowing to here or not. In most cases, you'd say, no, I don't want to allow access from the outside world to this. I will only allow access going in here, and then only allow from these guys to these guys. Okay, and you do that by defining security groups at each interface level. Now, once you define a security group, here, for example, you can take that security group, think of this as a little piece of paper describing who and what can access these machines. You can copy that onto all of these interfaces. So you've got the same security group across all of your machines. So when you add a new machine, you simply associate it with the same security group. And the same goes for these down here. Okay? This means that traffic comes in, hits web servers, and only the web servers can communicate with the backends. It's a good way to lock it down, right? Again, looking here at the console, this is what it looks like when you're creating or working with your security groups. As you can see here, we have a couple of security groups, one for the web servers that you saw on the previous slide and one for the backends, and they're associated with your VPC. You've given them a group name, and they have their individual group identifier, so you can recognize them by their group ID. But if you were to, say, click this and highlight the web servers and look below it in the console, you would see all the rules that are being applied. Therefore, whenever traffic comes in, maybe on port 80, which is a typical website URL, if you go to www.example.com, that's going to go onto port 80. And what this rule is saying is that any IP address, meaning anyone out there on the internet, can actually access the machine that has this web security group on it via port 80 and port 80 alone. Okay? So you have to define which ports are available and which range of IP addresses, either a range of IP addresses or, guess what, a security group could also go in here. In this case, for a website, you'd probably want the outside world to reach it, otherwise not much point of a website, right? So that's what a security group rule looks like. And what this is saying is we're having a custom rule here saying only on this port range here that we can have this range of IP addresses, or, as you can see here, see how they're linked? This is nothing more than a range of IP addresses when you think about it. If you've got a tag, or tag's probably the wrong word, a security group ID, that is referencing the security group rules for a set of machines which have IP addresses. So you're really doing what you did on the last slide by defining an IP address range here. Yeah? So you're saying the web servers can communicate with the backends providing they're going on this port. Okay? In English, only instances in the web server security group can reach instances in that security group. A couple of notes on this. You want to follow the principle of least privilege. Don't open up all your ports to every IP address in the world. Only allow access from machines that specifically designed to send traffic. In other words, if you have backend servers that need to be communicated by the web server group, only allow access from them. Don't allow access from the outside world. It's kind of common sense, really, that you wouldn't open up all the ports. But this is what they mean by follow the principle of least privilege. Okay? Sure, you can read this. VPC allows creation of egress as well as ingress security group rules, so you can control what comes in, what comes out. Generally what you do is you have a one-to-one relationship between your security groups and the IAM roles, and we're going to talk about IAM roles in a little bit. So let's look on connectivity options for VPC. How do you wire them all up? How do they communicate from one VPC to another? Let's explore that. Beyond internet connectivity, of course you can create private subnets and public subnets, and those public subnets can have machines in that can be reached by the outside world, typical website type stuff. But in many cases you might want to create a network in the cloud and have that connected privately to your on-premises data center. You may even have multiple VPCs, and you may even have multiple accounts or third-party accounts or partners that you deal with that have AWS accounts, and you want to communicate across boundaries there. So you might want to have one VPC in your dev environment communicate with another development team in a different part of your organization in a different VPC, possibly a different AWS account. How do we do this? Well, I mentioned before you can restrict internet access by controlling the routing tables of the subnet layer, meaning that if you don't have a route to the internet, guess what? It's a private subnet. If you do, then it is a public subnet. But that alone doesn't mean these machines are routable. You'd have to have public IP addresses on them as well, otherwise that's going to drop. The network ACL, as we mentioned before, can control internet access because it's determining what can and cannot move across the subnet boundary. What you're looking at on this page is an interesting technique where you have two VPC subnets here, and they're communicating from a private subnet to a public subnet, so that these essentially, by association, have access to the outside world. And you think, well, if I'm having a public subnet, why would I want these machines reaching the outside world? Well, what you're doing is you're saying any traffic destined for the local VPC is going to be routed locally, as you see here, but anything for the outside world isn't going to go to an internet gateway, like these guys over here. It's actually going to a network address translator here, or a NAT Gateway. It means that all the traffic can go to this subnet, and then this subnet can reach the outside world naturally, because it has an internet gateway on it. Why would you do that? These machines can now be patched. Yeah, because there's no point having machines in a private subnet and then you have a security vulnerability and you can't patch the machines because you can't reach the outside world. This is a mechanism for these guys to reach the outside world in a safe way without actually exposing them via an internet gateway. Very common technique, it's called a NAT gateway. So, connecting the VPCs together. Why would you want to do it? In many cases you have large organizations that want to have some separation of concerns, such as you might have the HR department or a legal department or a dev environment separate from a production environment, but yet in some way you still need to communicate across those boundaries. Things like centralized logging, you might have a remote administration, or you want to scan for vulnerabilities, that kind of stuff. You may even have an authentication directory where you need to communicate across those boundaries. So there are many reasons why you might actually want to have VPCs communicating across each other. And the concept for that is called VPC peering. And this is saying that if you have one VPC over here and a different VPC perhaps on premises, you might allow these machines that have a security group associated with them, which we've named Orange Security Group, they can communicate with the machines over in your private on-premises system that have security groups on them associated with called the blue security group in this slide. Now obviously on premises you probably don't have the concept of security groups, you'll be having firewalls, but as we talked about before, we match like for like, they're pretty much the same things. So what you need to do to establish a VPC peering system, all you need to do is initiate a peering request, and guess what? All you got to do is accept it. Once you have that, you need to go to your route table and say, well, any traffic destined for my local network is going to be transmitted locally. That's hidden below that orange there, that says local. Anything for the outside world is going to go to an internet gateway, right? And anything destined for this range of IP addresses, meaning on-prem, is going to go to the peering connection. This is a peering connection. Okay? This is a virtual gateway, and maybe we'll get onto that later as well. So you're creating your routes. Once you've created the request and accepted it, you set up the routes, job done. Okay? One other thing worth mentioning on this connectivity issue is you can use virtual private networks to communicate between your on-premises network and the one in the cloud. And you're going to do that with a customer gateway on your on-premises system, this time we're on the left, and then you have a virtual gateway in the cloud, and you'll communicate across both of those devices using what we call IPsec tunnels. This is going to be your networking device. This is one we have in the cloud for you, and we have two IPsec tunnels here to create high availability. And this allows you to send traffic from here to here and from here to here, providing you've set up those peering requests, providing you've set up the security groups and security rules and all those other things we talked about as well. Okay? What happens if you don't want to go across a public internet with that traffic? Well, if you like, you can create an Amazon Direct Connect, and this is going to allow a secure connection between your network and your VPC. And Direct Connect is a dedicated line with lower per gigabyte data transfer rates. Great for high availability, and it just gives you a better, more consistent bandwidth. Yeah, because the public internet can be a little flaky. If you have Direct Connect, it's a lot more stable, and it allows you to transmit a consistent amount of data. And finally, let's just talk about how the VPC interacts with the rest of the services within AWS. I mentioned earlier on we have something called RDS, your Relational Database Service. That can sit inside your VPC, and what happens is when you have a machine here, which is essentially a database, you can communicate with that providing you set the security groups up in place, and it's resolvable by a DNS name, which resolves to the IP address range that we've provided for your RDS instance. So communicating from your instances to things like RDS and Dynamo, these things are quite straightforward. The challenge is when you start communicating to things like S3 and Dynamo, generally you'll go across the public internet for them, which isn't ideal. Most people would like to communicate from their entities to services like S3 and Dynamo, which are regional services. You'd like to be able to communicate to them, but not actually leave the VPC. And now we have an ability to do that with what we call VPC endpoints. So normally you would send your traffic to S3, and we'll talk about S3 later on. But we would send traffic over to S3 and maybe store your items in here, and you can go across a specific VPC endpoint, and that means that you don't have to go via the public internet. How do you set that up? Well, you define this VPC endpoint here, as you can see, VPC endpoint, in your routing table to say any traffic destined for this tag here, this PL68, this is nothing more than a range of IP addresses identifying items within or destinations within S3, and that can then be targeted a specific VPC endpoint. So when you communicate with S3, it's not going across the public internet. You can use a very specific endpoint and directing it specifically to your VPC via your VPC. And you can do the same with Dynamo as well. And of course, like all things, you can lock things down even further with bucket policies. We haven't talked about that yet. We're going to get onto that when we discuss S3 and other things like roles. But generally, locking things down is very, very easy, providing you follow the principle of least privilege. Finally, just let's talk about VPC logs. All the traffic coming in and out of your VPC, or even to the interface level, can be tracked if you enable VPC Flow Logs. All you've got to do is set up flow logs, as you see here, creating a flow log. Once you've set that up, as you can see here, this is what it would end up looking like. This is showing you which port the address came in on, whether it was rejected or not, and you can see a time series event showing which entity was approached, what the IP address was, and the DNS ports. In this case, because it's 53, which is the DNS port. And you can see whether it was accepted or rejected. So that's it. VPCs is your private network within AWS. Let's have a look inside the VPC now, and let's explore EC2. EC2, other than S3, this is probably one of the most common entry points to working with AWS. One of the first things that I experimented with when working with AWS back in the day. It is an instance of compute power in the cloud. All you're really doing is purchasing or essentially renting a machine in the cloud for a certain period of time, and when you're done with it, you stop paying for it. Okay, it's very straightforward. If you're happy with it, you just keep it running. So that's how EC2 works. It's resizable, meaning that if you start with a tiny weeny little EC2 instance, and I'll get into sizing types in a little bit, and you find that that's not doing what you need, not a problem. You can just scale up and get a bigger machine. So it's a resizable compute capacity. With that size of machine comes various categories. We have things like high memory usage, high CPU usage, that kind of thing. And again, I'm going to get onto the exact details in the next few slides. It does give you complete control of your computing resources. Once you launch your Linux box or Windows box, you can go into that machine and you can configure it as you choose. It also reduces the time required to obtain and boot new server instances to minutes. If you were to launch a new machine, you don't have to go and buy a new server and install all the operating system. You can literally click a few buttons in the console and you have an instance in, as it says here, minutes. So you can scale your capacity as your computing requirements change. We mentioned this. You're only going to pay for the capacity that you use. That's the whole point of this. And there's two types you can go for. You can go for Linux or you can go for Windows. Once you have decided on what type of machine you want, you decide which region. You may say, I would like this to be in California or Tokyo. Once you decide on a particular region, you can then go into where exactly in that region it's going to go in terms of the availability zone, which we talked about earlier on. And ideally, for high availability, you want to put your compute resources in more than one availability zone. So if one availability zone got hit by a meteorite, at least your operations are still going to carry on because you've created high availability by putting your resources in another AZ. So how do you launch an EC2 instance via the web console? It's actually very easy. All you need to do is decide on a region. So you're specifying, where's my stuff going to go? Are we going to put this in California? Is this going to be in Tokyo? Once you decide on a region, even though it's not saying that on the slide, you would then go and look at a specific availability zone and drop it in there. And ideally for high availability, of course, you put your instances in more than one availability zone. So if one availability zone got hit by a meteorite, at least your operations still carry on because you've created high availability. Right? We talked about that a little earlier. So you would launch your Amazon EC2 instance from a template, or what we call an AMI, Amazon Machine Image. This defines whether it's going to be a Linux machine or a Windows machine, that kind of thing. And once you have your template, you need to specify a few other things. How much CPU you're going to need, how much memory you're going to need, whether or not you need certain types of storage associated with that instance. You're going to need to put these things in place before you get to the final step of defining things like the network configuration tagging your instances, deciding on public or private IP addresses, adding security groups at the interface level, or adding some other user data scripts that will run when the machine launches, that kind of thing. But you need to get all the other things in place first. It has to be region, has to be the template, then the type of machine, and then the finer details. Okay, once you have those things in place, within a few minutes, you have your machine. Let's talk a little more about that AMI. Excuse me. So an AMI includes the following. It's going to be a template for the root volume, such as an operating system, Windows, Linux. Then you would choose the permissions that control which AWS accounts can use the AMI to launch instances. If you want to, the AMI that you're creating can be launched by just yourself, people in your organization, or people outside your organization. So you can define that, because you don't want to create a machine that just everyone can go and launch. You might want to lock that down a little more. You would also define the block device mapping. And what this does, it associates storage volumes to the instance you're launching. Looks a bit like this. Talked before that you need a region, choosing the operating system, type of architecture, and then who can launch it. And once a valid user decides to launch an EC2 instance from a template, it defines the storage that's associated with instances, and then you're up and running. So one of the things that's worth mentioning related to these EC2 AMI templates is that you could just use one of the standard ones that you get from the console, or you can go into the AWS marketplace and choose an AMI that has been configured specifically for a task, such as you can see on here, Sophos or Oracle, right, or TIBCO. MongoDB would be another example. The example would be if you could launch MongoDB onto an EC2 instance, like a database, and you launch that onto an EC2 instance. You could do that yourself. You could configure all of that yourself. But why do that when you've got the people behind MongoDB creating and configuring an EC2 instance just perfectly for working with MongoDB? You're better off using AMIs or templates from the marketplace to do specific tasks or use specific software than you are configuring it manually. Most of these are free, meaning that you can just use a template that they've provided because they want you to follow best practices. But in some cases, namely people like these, they have licensing involved. So how does that work? Well, if you already have an existing Oracle license and you want to launch an Oracle AMI in the cloud, you can do that. You can bring your own license. That's what that stands for there. You can bring your own license, and then you don't have to pay a premium on the hourly rate of renting your machine. And that's how this marketplace works. These providers, for those who are charging for their AMIs, charge a little premium on the hourly rate on your machine. So you pay your normal EC2 rate, then you pay a little bump, which is what they're charging you, and then you get the machine with the perfect AMI. Okay, so that's how that works. So here's a diagram showing EC2 instances being launched from AMIs. Those instances go into a region. This could be California, and then you decide on a particular availability zone to drop your instances in. You associate those storage volumes, which is what you're looking at here. These are storage volumes. Think of them as little hard drives that you plug into your machine. And once those hard drives are associated with those machines, you're up and running and can operate. And depending on how you set your VPC up, traffic could be flowing in and out here, etc., for high availability. This area here that you're looking at is S3. We're going to talk more about S3 a little later on. It's just a storage data lake where you can store a ton of information, many objects such as database backups, storage volume backups would go in there. They call these EBS snapshots. So if you take a snapshot of this volume, you can store that durably in S3 across the whole region. And because it's available across the whole region, hence its durability, you can then replicate the EBS volume back here. So if you had volume data, and I should probably change the ink for this, you have some volume data in here called A, you can save that as a snapshot. Later on, you can then create a clone over here and copy the data from here all the way over here, because you can't go from here to here. There's no way to do this, by the way. This is one set of buildings, this is another set of buildings. You can't do that. What you have to do is you have to save it to a regional service like S3 that will replicate your data across the entire region, all the AZs, and then you can restore from S3 into another AZ. So that's how that works, okay? Two types of storage mechanism. You have the EBS volumes, which you saw here, right? So actually just going back to this slide real quick. You can store your information on these EBS volumes like this, right? Or if you wanted to, you could imagine you've got a little EBS volume in here inside the machine, and you can store your data inside the machine. Problem, what happens if that machine dies? You've lost that data, haven't you? Okay, so that's what this slide is referring to, is that data stored on EBS volume can persist independently outside the life of the instance, and the storage is persistent. And that is not true where you store information on the machine itself. Data stored on a local instance only is going to stay there as long as the instance is alive. When you stop that machine and terminate that machine's gone, so's your data. Okay, if you've done this, that's not a problem, because even if this machine dies and it had this associated with it, that's fine. Not only can you snapshot this, as we talked about before over here, back over here, you could also just go boop, pop it in there. Yeah, done that slide. Okay, so choosing the right EC2 instance. With this, there are certain things that you need to think about when you're launching an EC2 instance, such as how much memory is it going to need, what type of network performance is it going to need, what type of storage mechanism you're going to use, CPU usage, this kind of stuff. And when you're considering these type of things, one thing you should be thinking about is the type of processor that you're going to be using on that machine. Now, I don't want to spend a lot of time talking about the inner workings of the processor technology that Intel have. I don't think this is the place for a conversation like that, but just know that there are different types of processor do different types of things very well. Okay, so as you can see here, we have different types of architecture. We have where we have Haswell microarchitecture, which is going to boost your applications by 30% or more. PNC state control, Intel AVX2 for handling floating point and compute-intensive workloads. If you're dealing with maybe handshaking, SSL encryption and this kind of thing, you might want to use this type of processor. Okay. Or you might want to use turbo boost technology, to boost the performance and it adapts to spikes in your workload if you have a very spiky workload. And in some cases, if you're doing high performance computing, you might want to use AVX. Also enhances video and audio and images. So as you can see, there are different types of processor that these guys create that do certain things really, really well. From a high level, here's what you want to think about. If you're doing a lot of high-powered computing processing, and you're using, say, this type of processor that has this feature on it, it would make sense to switch to a processor that uses this. Because if you do that, you're going to get through your workload a lot faster, and therefore it's going to cost you less money. So really, you want to have the right tool for the right job. Now, the challenge with looking at all of these types of architecture is it's very difficult to know which machine to use at a glance. And so what we do at Amazon is we've created this system where we use letters and numbers to identify the type of machine, so at a glance you can figure out what type of machine you should be using. Example being, I need a high memory machine because I'm running Redis, for example. I'm doing a lot of high memory stuff, or running Node.js. I need high memory. Well, then you use an R instance, R for RAM. If you need high compute power, C for compute. Need graphics processors and machine learning, you might use a graphical processor that has all these different types of processor technology and designed specifically for that type of task. Maybe you're running MongoDB, you need lots of fast reads and writes. Well, in that case, you need a high I/O optimized machine with these type of technologies, and you would pick an I machine. You need dense storage, not a problem, use a D type of machine. When I first saw M, by the way, I thought, oh, that means memory. No. I think of that as middle of the road, mainstream machine. If you want high memory, you're going to use an R type machine. In fact, we have a new one, which I'll get into later, called an X, which is really high memory. The one on the left here that you see, the T, this is slightly different than all the others. This is to do with burstable technology, meaning that if this is your typical traffic on a website, like that as a graph, there's your traffic coming in and out. It's very spiky, and in some cases it might be really spiky like this. So what you can do with a burstable instance is you have a baseline performance, and I'll change ink here. You have a baseline performance, and then it can handle these spikes because it works on a credit system, meaning that while you're not having these spikes down here, it's building up credits. And those credits can be used to handle spikes. The alternative is to just use a normal baseline system, like one of these guys, and you have a baseline like that. But it doesn't handle spikes as well as this guy. So, great for websites, where you handle spiky workloads. But if your machine computing task is very consistent, you might be better with some of the others. And again, so these are the different types: burstable, main, middle of the road type machine, one size fits all. It kind of does most things you need. High compute, high memory, high GPU, I/O, and dense storage. And that syntax and using this T, M, and C avoids you having to get into the details of this stuff. Okay, the number that you see on the right, that's the iteration. So an M4 is just like an M3, but just better and newer. You get the idea. This is just a chart showing what I just talked about, pretty much. The different types of machines are good at different things. High memory, 3D application streaming, T2 is great for websites, and even M4s, M3 for legacy. So I want to talk a little bit about the instance that you launch and the metadata surrounding it. When you launch an EC2 instance, you have a few options. You could say, I would like my machine to run a script when it first launches or first instantiates. That may go and download Apache or download some other software or get something from S3, that kind of thing, before it becomes active. And that would be what we call user data. This is a script that you pass in, and it will run it when your system is instantiated. Great for things like configuration and just general getting up and running stuff. That user data, along with other meta information such as the IP address that the interface is on, that kind of thing, is all encapsulated within something called metadata. So user data belongs to metadata. And metadata is just data about your instance. And it's great because you can go into your instance and inspect that metadata. I'm not going to get into the weeds on this, but all you need to think about is that there. That is the IP address that you use when you're on your machine. If you go into your machine, maybe on a Windows box, and you go to that URL here, you can then go into the metadata and find out all the information on your machine. Okay. On a Linux machine, you can do this. All it is text returned back to you defining many things surrounding your machine. Now the other option, of course, is you can go into the console and see all this stuff. But it's sometimes very useful to retrieve instance metadata on the machine itself. Okay. Oops. So that user data, let's get back to that. You can either use Linux script, which is executed by CloudIn, or Windows batch or PowerShell scripts executed by EC2 config service. And the user data scripts are going to run once. Okay, so they run when they instantiate. When you reboot your instance, it doesn't restart. Okay, it doesn't redo your user data script, it doesn't rerun it. What you're looking at here is a typical example, maybe a Linux script, and this is a user data shell script that you write. For those of you familiar with shell scripts, you might recognize some of these things. All this does is goes and installs in Apache without installs in Apache without you having to press Y all the time. You know, when you install something into a machine, it says, do you want to install this? And you go, yes, 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 yes. Well, the -Y stops you having to do that. This is going to install Apache, it's going to check it's all working, and it's going to kick things off. That's a typical user data script that you would run when your machine instantiates, right? Windows has its own style, like that. Similar to the previous slide where I was showing Internet Explorer displaying this stuff, well, you can use the same stuff here. Go to that URL and get the user data that belongs to the metadata, and you can see that it prints out your user data script here. Alternatively, you can look at it in the console, which is sometimes easier. But again, it's kind of helpful to be able to go into your machine and access this information, right? Okay, let's talk about purchasing. It should really be called renting, I think. It says EC2 purchasing options, because what you're doing is you're renting a machine for a period of time, and when you're done with it, you then terminate it, and then you no longer pay for it. That's the typical on-demand stuff. Everything that we've talked about so far has been alluding to the idea of an on-demand instance. You pay by the hour, run it for 3 hours, guess how long you pay for? You pay for the 3 hours. Okay, it's very easy to use, very easy to set up. In many cases, or in fact almost most cases, you're better off not using that. Okay, ask yourself this: if you have machines, for those of you using the EC2, if you have machines in the cloud that are on demand, how long have they been running? If they've been running for more than a couple of weeks, or even a couple of months, or in some cases a couple of years, you would have been much better off using a reserved instance. Because what you're doing there with the reserved instance is you're contacting us ultimately and saying, I would like to have this machine or rent this machine for a long period of time. Okay, maybe a year, even 3 years. And as such, I want a really good deal on that hourly rate. And that's really what you're doing, is you're purchasing a significant discount by either putting some money up front or tying in for a longer term contract. And again, I'm going to refer you to the docs for the details. But the idea of reserved instances, a reserved instance could save you up to 75%. This is not a trivial saving. This is a significant saving. You imagine companies that are spending hundreds of thousands a month on demand, switching over to reserved instances. Going to save a fortune, aren't they? So why wouldn't you always just use a reserved instance? I think this is probably it. Committing to 1 to 2, 3 years, you know. No one wants to do that because what happens in maybe 6 months' time, if you've committed to a 3-year project, in 6 months' time your project dies, are you then locked in for the remaining period? Well, technically yes, but here's the good news: you can use the reserved instance marketplace to resell your remaining time to get yourself out of a contract. It's a bit like getting out of a car lease. Okay, you can pass that on to somebody else. Okay, same sort of concept. I would suggest in all cases, unless you're just experimenting or poking around with a project, you should always be using reserved instances. You only really use on demand for experimenting. This reserved instance can also be scheduled. And you could say, I would like to run a report at the end of every month for 2 to 3 hours, and then you're getting a reduced rate on that. You're only running it during those times, maybe every Tuesday morning, every Wednesday afternoon. You're scheduling them, and then you're only paying for when they're launched, and you're paying for them at that reduced rate as well. So that's a different type of RI. We use the phrase RI to stand for reserved instance. And then we have spot instances and dedicated hosts. Let's talk about spot instances. This is essentially naming your own price. The marketplace will change over time, right? So, and that varies per AZ as well. So the pricing of your instances can vary. The marketplace price for the instance varies across different availability zones. So you imagine the pricing is like this. Okay, this is price up here. Over time, maybe Sunday night or 4 a.m. in the morning on Sunday where we've got really low traffic, the marketplace price, or the going rate as we should say, is really low. Maybe at peak time it's very high. So what you can do is you can come in here and say, I would like to purchase if the price ever drops below that value. So you specify a price that you're happy to pay. If the marketplace fluctuates, which it does, and then drops below here, you then get your instance, provided the marketplace doesn't rise above your price point. Which is great. There are some downsides. The downside to this is when the market price changes and goes up again, you lose your machine. I can give you good news and bad news at the same time. You get a 2-minute warning. Okay, so in some cases this works really well. If you had perhaps a cluster of machines, say you had a cluster of machines doing a task, and then you said, well, why don't I name my own price and try and get a few extra machines at this lower rate, and then your job can complete faster because there's more machines working on it. And if more machines are working on it and completing the job faster, you're spending less time on these machines being running, so you can kill them off quicker. So therefore you save money on your existing machines and get your job done faster, because these are at a lower rate and these are run quicker. You get the idea? So spot instances can save you a lot of money, not only on the machines you're launching, but it'll save you your time per hour rate on all your other machines as well. And if this machine happened to die because it was at this price point and the price went back over and above your price and this machine was killed off, I should probably use red here. If you've set this up correctly and done it as a cluster, it's okay to kill one machine because the rest of the machines can adapt. Maybe you've got auto scaling, bring in another machine here, that kind of stuff. There's mechanisms you can put in place to make that 2-minute warning thing not sound as bad as it sounds. Yeah. Would you use spot instances for websites? I'm not so sure. Maybe for clusters, batch processing, that kind of thing is great, because if you can add more machines, wonderful, you get your job done faster. And if you can't, well, what have you lost? Nothing. So, spot instances or naming your own price. And finally, dedicated hosts. There's not much to say about this really. This is where you're dealing with a compliance issue. Perhaps you have a company that says my apps can't be on the same machine as other EC2 instances running, and that you need complete isolation of physical isolation. Very often that can be for compliance issues, or it can be perhaps even for licensing. You might have a license that has a per socket or per core type license, and you've already bought that and you want to bring that over to the cloud. Well, in order to do that, you're going to need to have a dedicated host to take advantage of that and save money. That's really all that does. It doesn't give you any performance boost just because you've got the dedicated host. If you're trying to do high-powered computing and gain performance, there are other more advanced features like placement groups. But dedicated host is more to do with compliance and licensing. It doesn't give you any more benefit than a typical on-demand or RI. Okay? Just a quick heads up before we jump into this demo. I actually had to pre-record this demo in advance because there were certain areas that needed to be masked out. So if you see these horrible blue blocks, that's me doing amazing post-production. Okay, hope you enjoy the demo. So here I am logged into the console. It's very easy to get around this console. All the services when you first log in are going to be exposed here. You're going to be able to type a service like S3 for example and click on this link, it'll take you straight through to S3. Or you can click the recently visited ones, which also actually appear here in your history. So as you can see from the services drop down, what you're looking at here, which can be grouped or even done A to Z like this, is exactly the same as what you see on the home page here. So it's very easy to find something like code build, for example. Whoops. And you can click that and just go to code build. If you want to switch to a different region, easy enough. Just go in here, switch it out the region, and then you'll see the region change up there. And then it'll be selected for, say, Oregon. Okay. So easy to navigate around as far as clicking on services here, or going back to the home page. The resource groups, if you've happened to have tagged many items, maybe tagged EC2 as production or test, you can click on one of your resource groups that you've created and you'd only see the resources that are related to the tags that you've set up, which I find also quite useful for different projects. Finally, one other cool thing I'll show you on here is this section here. If you use something frequently, say you use Cognito, you can just drag them up here like this. I find them extremely useful, and you don't even have to have icons on text, you can just swap them out like that. And then when you're done with them, you just click that and then you click on OpsWorks, takes you straight in. You get the idea, okay? I find that extremely useful, and drag them off when you're done with them. Alright, so let's go back to the home. So that's navigating around products. There are some links here for how to explore AWS. You look at the marketplace, submitting feedback, all these other things. I've already shown you the regional one. This is alarms, meaning if you happen to have created an EC2 instance and left all the ports open and that kind of thing, it might pick up these under your personal health dashboard to let you know if there's issues about scheduled maintenance on RDS, this kind of stuff, all available within the personal dashboard there. So that's kind of useful under alarms. And then under here we can look at the account information, of course. Opens up in a new tab, brings up all your account information. Cost Explorer is kind of useful too, because this shows you exactly what you're spending on particular products. Breaks it down into AZs, regions, and products. What I find really useful on this is to be able to forecast, 3 months ahead. It's like, well, what am I likely to spend? Sometimes they get it pretty spot on, actually. We could spend a lot of time on Cost Explorer. I'm not going to go down that rabbit hole, but you should definitely play around with that. It's very cool. Organizations, that just refers to if you are in a large organization, you have many groups and different AWS accounts, you can coordinate them all with AWS organizations now. What else is on this menu? Let's have a quick look. Switching roles, so if I don't want to be in a different role, I could just swap that out. I can sign out, obviously. Check my security credentials. I think that's all there is there. So the only one left is this one on the right, called support. So let's just go back to my homepage here. Let's talk about the support. Under support, you have a support center. You can go here and create cases such as, trying to get an increase on soft limit for email, for example. Ask you what region. Ask you a few piece of information on your email type. You type your message, you submit a support case, and then you can track it all with the dashboard over here. Okay, so that's how you raise a support ticket. Forums, kind of common sense as well. If you want to learn how to use an S3 upload, you could click that. Whoops, and it would walk you through it. Also kind of cool. Let's go back to the console. And that's pretty much it, I think. Other than a plug for training, check out our training inserts and which catalogs we have for all different courses and how to schedule a course. That's a little bit of a plug for the division I work in. But other than that, I don't think there's much else you have on the console. I'll leave you with other resources as well. If you just want to get started with a 10-minute tutorial, these are great. You just click on these, literally walks you through it step by step with nice big images and all that fun stuff.